Hello, welcome to today's online panel discussion that we have titled Beyond the Visible, Imaging in IR, NIR, SWIR and Hyperspectral. My name is Mark Elliott. I'm the COO of Europa Science, which is the publisher of Imaging and Machine Vision Europe. We have a bold plan today to explore a really fascinating topic brought to you with our partners Navatar, which is an Amatech company, because we know imaging beyond the visible spectrum is revolutionizing machine vision. It's unlocking new possibilities in precision agriculture, food and pharma inspection. It's doing great things with thermal monitoring and material identification. From infrared and near infrared to shortwave, infrared and hyperspectral imaging, these advanced technologies are helping industries detect defects, analyze chemical compositions, and monitor processes in ways not possible with standard visible light imaging. We've got a bold plan today because we really want to explore how this helps solve complex challenges, how to improve the quality control of all of that, understand how this optimizes manufacturing processes, and obviously understand where the new application areas are coming from. I am very pleased that with that no small challenge, I've got three excellent participants in this discussion to help me. We are having some technical challenges with one of them, so I'll come to him last. But I wanted to first of all introduce Philip Stampf. He is the product manager at CIA. Philip leads product development at the Ocean Focus Machine Vision provider, CIA, which is overseeing AI-based imaging system creation for detecting and identifying objects in the sea. It's been at the company since 2020 and is currently tasked with applying thermal imaging cameras towards monitoring water surfaces for debris, which obviously helps avoid collisions for ships and boats. Prior to joining CIA, he served in development and mechanical engineering roles at SINN Power and Voestalpine, and holds a Master's of Science degree in mechanical engineering from the Technical University of Munich. Very pleased to have you on board, Philip. Then, no stranger to us at all, we have Brian Wilson. Brian is the president and CEO of North American Coating Laboratories, which is a leader in advanced optical thin film solutions. Brian is a second generation owner and has really driven that company forward with a reputation for innovation, precision and customer-driven excellence. Has a degree from the University of Rochester and a background as an optical thin film engineer, and it brings a lots of technical expertise. Brian's no stranger to this sort of environment. He's actively involved in contributing discussions on lots of emerging technologies and industry advancements. And for that, and among many other things, he was recognized for his achievements when we launched the Photonics 100 back in 2023. So welcome, Brian, as well. I don't know that Faisal is going to be able to join us quite yet, so we will come to him. I'm going to give him a name check anyway, because he is also a Photonics 100 alumni and has helped us out on many of our webcasts previously. He is a principal technology analyst at Sony, joined the Photonics 100 last year. Has got a range of work areas from biophotonics, sustainability frameworks, hyperspectral imaging, quantum, you name it, he's sort of all over it really. He's currently involved in developing a hyperspectral imaging camera, which has got the highest combined spatial and spectral resolution, addressing a major market gap for high-end R&D, particularly in the healthcare space. So welcome to him. Hopefully he'll be able to join us. If not, and if anybody wanted particularly to get in contact with Faisal, just give us a shout, drop us a note and we will get your questions over to him. So welcome to our two speakers who have made it through. I just want to do a little bit of quick housekeeping and then we'll get on to the real meat of the session, which is that these online panel discussions are designed to be useful and interactive. So obviously we will welcome any questions from you watching. So please submit them at the bottom of your screens and we'll do our best to tackle them across what I hope will be a full and lively discussion. Right. Just down to two, we will make this work. We'd always like to have a good range of views at these sort of sessions, but I know, Brian, Philip, you'll be really good at covering a lot of ground for us here. So I'm going to start, if I may, with a relatively general question just to get ourselves warmed up. And I wondered if both of you, and I'll come to one of you in turn, if that's okay, could just outline the fundamental benefits of using non-visible light sources for imaging versus, say, visible spectrum lighting. So, Brian, I'll come to you if I may first.
Sure. So, obviously there's a lot of different things that infrared imaging can be used for that vary from the visible spectrum imaging. Things like thermal imaging for, heat detection for a variety of different uses, low light and no light operations. For near infrared, there's a lot of material penetration and surface characterization, things that can be used. I think it's, I won't specifically get into that. I think the next question may have more involved with the individual types of things, but just to make sure that we're clear on the understanding that when we're talking about near IR or shortwave infrared versus what we kind of traditionally call just infrared, near IR is typically defined as like the 780 nanometers to 1400 nanometer wave band. Shortwave IR is typically referred to as around 1400 to 3000 nanometers, and then infrared is pretty much anything above 3000 or 3 microns. So, but the other things that it can be used for are kind of like moisture and chemical sensitivity testing. There's a lot of reduced glare and scattering. So, again, I think the next question we'll get into more details about what these things are used for, but those things that I just discussed are typically problematic when using visible light imaging, and those things can be solved by using a variety of different infrared imaging techniques.
Okay, thank you. That was a really good overview and an introduction to this. Philip, anything to add to that, or in terms of your
Yes, of course.
perspective?
Yes, of course. So, I mean, our mission at CAI is to increase safety at sea. And first of all, we want to solve a problem. And the problem is that there are still lots of collisions and there's still lots of risks when you are at sea. And therefore, we were looking for sensors which works 24/7. And I mean, it might be obvious, but that's the main reason why we use thermal imaging. It works day and night. And even as a normal operator at sea, looking out at the during the dark, you can't see anything, and this is where a thermal image camera makes the difference.
And in terms of the journey that this kind of technology has been on, have there been have there been breakthroughs in understanding about these benefits, do you think? Was there a kind of great leap forward in terms of general understanding around what this can be used for? Was there any kind of product that kind of changed that, or some sort of application example that really fundamentally changed the belief system about about this technology type? Um,
Thermal imaging, you mean?
Either really,
Yeah.
I guess, anything. I mean, just in terms of general kind of application usage, really.
Yeah, so I mean, I'm working, or our company is working in the maritime field, and the maritime field is not very famous for being innovative and acting fast. So this is a very traditional industry, and therefore bringing a new, it's not new, but let's say a powerful technology like thermal imaging or even cameras like normal visible cameras on boats, on vessels is already an achievement. And here, let's say there is still a lot of opportunity to add more cameras, more technology, more sensors to boating. And as in boating and maritime world, night vision is important. That's why the thermal image sensor is the way to go.
Okay, and what and Brian, from your perspective, of course, you're working in a range of application areas, I'm sure. Can you kind of detect a kind of gear change in the way that kind of application has been kind of understood and then utilized?
So similar to what Philip was saying, one thing I've been reading a little bit about is that it may become a requirement for vehicles, cars and trucks and so forth, to have some sort of thermal sensors on them to avoid collisions with like animals at nighttime. I know that's been discussed in the European marketplace recently, is making sure that it becomes a requirement for all vehicles to have some sort of an automated system that uses thermal imaging. So if a deer runs across the street in the middle of the night, and you can't see it with traditional, headlights and other things like that, that the car will detect it automatically and avoid collisions. We also, a lot of what we do is with regards to military and tactical usage. So a lot of things are used infrared imaging for those applications in military, missile sighting, night vision goggles, things like that. So But what's really interesting, I guess, kind of about my position here is I can be a little bit dangerous with regards to some of the technologies used, but because we are the coating company, we're taking substrates provided by our customers, modifying the way that light interacts with them and somehow to create a different performance. But sometimes we don't even know what these infrared optics are used for. And sometimes if we ask what they're used for, they say, don't worry about it. Just go ahead and put the coatings on according to the specifications. So I'm not going to be maybe quite as well versed as others maybe in terms of all the different usages of what these infrared sensors can be used for, but I can certainly comment on the things that we've been directly involved with.
I understand. Yes, it's a bit like a kind of don't ask, don't tell type.
Exactly.
stuff,
Yeah,
exactly.
exactly.
Or if I tell you, I have to dispense with you in some way
That's right.
going forward.
Right.
Faisal, I can see you're here now. I don't know whether you're able to contribute. We're just having a general discussion about the kind of context, really, which is the fundamental benefits of non-visible light sources for imaging versus visible spectrum lighting. Have you got anything generally to add about the context of that? You know, what you would define as the obvious helicopter pitch around this?
Sure. First of all, my apologies for a little bit of a disconnection before because I'm traveling. I'm not sure what my colleagues, other panelists have talked about, so I might run into the area of redundancy here, but please bear with me. My thoughts perhaps are how we sort of compare the visible versus non-visible. And in these benefits, generally can be summed up that it allows us to see what can generally be unseen, which is generally unseen in the visible spectrum. Then now the applications kind of differ from one point to the other, and technology to technology, whether it's the IR side, infrared, that can capture thermal emissions from objects, sort of where you can differentiate between them based on the temperature side, or you're looking through the object, which is the penetration through materials. So that sort of opens up a transparency window where the visible light cannot hit. Visible fog, smoke, water vapor, even a certain solid like silicon that can become transparent to these wavelengths then. So then the application kind of is pretty broad. In industrial and scientific context, you can think about the non-visible illumination that allows systems to detect hidden defects, could analyze chemical compositions and monitor process in the ways not possible by the standard visible imaging technologies then. So anywhere where you require an unseen pattern or an observation to be highlighted, I think the non-visible light becomes the key, whether it's through the transmission mechanism or through the reflection mechanism. You can think about the signatures of the night visions versus UV fluorescence for forensic inspection, or even infrared absorption features for the material identification. So all of them essentially, for me, stand as a key benefit compared to the visible light spectrum.
Okay, thank you. And that's a good segue into the next question, really, which is about the kind of the differences in benefits, and obviously the ability to actually see is, I suppose, kind of where you start, right? You know, they work 24/7. They're not necessarily dependent on natural light, for example. I mean, how do you kind of, when you get a kind of an application discussion going, how are you able to differentiate between one type of non-visible lighting from another? Is it very much a case that people are coming to you with preconceived ideas, or are you discussing, you know, the options almost as a sort of blanket set of approaches to a particular problem area? Brian, I'll start with you, obviously, because I know obviously you're dealing with a broad range of kind of contexts, right? How does that work in practice? How do you kind of advise partners about what choice to make in terms of those different lighting choices?
Sure. So oftentimes, by the time it gets to the point where the optics need the coding application, which is what we do as a service, the decision for what type of infrared material, imaging system, cameras, sensors, detectors has already been selected. But I can tell you about a couple of the novel ones that we've worked on specifically. One of the ones that I thought that was really interesting was for firefighters. Some of the new novel firefighter helmets have both visible and infrared technologies built into them, so that as the firefighters enter to a trauma situation, once they're in there and they're immersed in, kind of like Faisal said, whether it be debris, smoke, dust in the air that they can no longer see through, infrared imaging will allow them to see through all of that, including even seeing through walls to see if there are still people within a troubled situation that they can identify and try to rescue. Another interesting application was one that we worked on for a camera that's been used on some kind of like archaeological and topography mapping for. They've recently been finding some pretty ancient civilizations deep in the Amazon jungle that have been forgotten for hundreds of years due to natural catastrophes and things like that, that if you just send drones or normal visible imaging over, all you see is a rainforest. But with using proper imaging techniques that can look either through that first level of forestry or even in some cases below the surface of the ground and into the dirt and some of the debris that's on the ground, they've detected ancient civilizations that they are still now starting to uncover. And apparently there's hundreds of them out there. So, there's just a huge range of applications for these things, but specific to what types of infrared imaging are used, long wave infrared is usually used for thermal detections, some of the night vision stuff. I think the short wave infrared or the near wave infrared is a lot of times used for more like material penetration and surface characterization. Like I think, in the agricultural areas, they can detect bruised fruit that may not be visible on the surface of the fruit before it gets, into the grocery store like that. They can kick out a fruit that is subsurface bruised, but they know that within a day or two, that bruise is going to come to the surface and become an unusable food item. So, I think there's some use in counterfeiting for, detecting counterfeit money and things like that. So just a huge host of opportunities for thermal imaging, night vision, infrared imaging that go well beyond what the visible can do.
Okay, that's great. Thank you. Good, really interesting. I think I read about that, the South American kind of civilization stuff. It's the sort of headline project, right, that gets so much kind of media attention beyond, say, the core technology interests that we often have. Now, just before we move on to the other two panelists on that point, I just had somebody message to say that he is involved with an organization called CEA, which is a French RTO, which is currently building a project on thermal imaging for AEB. So he's happy to share details if anybody watching this is interested. So he just wanted to flag that and stuff. So that's worth everybody knowing. Philip, from your perspective, then, I mean, obviously some of these different imaging systems, I guess, work better in water, right, than others. Is there any much differentiation from your perspective?
So I fully agree also, or I have the same perspective of Brian. Actually, it starts, let's say, with the problem or with the use case. Imagine if for a person who wants to have a collision avoidance system based on camera, but this person is only sailing during the day, there is no need for, let's say, a thermal camera, which is very powerful, but obviously it also has its price. On the other hand, when you need to work 24/7, then you have there is no other chance than using thermal imaging. But the big strength, I think, is also to combine the sensors and to combine the strengths of each sensor. For example, a normal visible sensor, you have a way higher resolution. That means you also can see further, and also the price advantage of having it. And the thermal sensor, on the other hand, is very powerful in see through the night, but also detect objects like imagine a person overboard, a person in the water. So that's why with search and rescue organizations, we work together also to detect or to help them, to support them with a system in the mission of saving life at sea.
Okay, no, that's fair enough and things. And then Faisal, from your perspective, I mean, are you able to, in the work that you're dealing with or around, are you able to routinely, kind of segment different kind of imaging solutions for different needs? I mean, this is something that crops up regularly.
Absolutely, and I think all of these solutions exist because there's a differentiation of the need. Whether you are going in the IR, near IR, or shortwave domains, different wavelength spectra are used for very specific applications, and both panelists have already touched on most of them. Whether they're looking at only NIR side or actually moving towards the more SWIR or even in the ultraviolet range. One limitation is in the NIR side is that it relies on active illumination in the dark settings. So since it's a reflective light imaging process, but these safety. But looking at the SWIR side, maybe a couple of additions could be beyond the food processing and the agriculture side, which was already mentioned by Brian as well. silicon wafer inspection is kind of a really cool use case. You can also think about the black plastics, for example, which are used in recycling and packaging, and they look identical and visible.
Okay.
You can basically show different SWIR signatures, which enable then the automated sorting of different domains. And Sony has actually recently produced in-gas sensors, which are their SWIR-based sensors, and they are the top of the range in terms of their resolution. And this is kind of a really attractive for the European market when it comes to semiconductor manufacturing, pharmaceuticals, solar panel inspections, etc., and even in the recycling markets. Then.
Okay. We're losing bits of you there, Faisal. Apologies for that. But yeah, I think we got the gist of that. Thank you. So moving on to kind of Brian specifically, I mean, obviously you're dealing with a lot of different customers. Could you share some of the key learnings you've gained in the last few years while you've been working on specific customer projects, say involving infrared coating production, for example? What are the big highlights of how that process works for you?
So for sure, it's a different similar but different technology than what we used to do. So for years we would go to trade shows, and this is prior to us getting into doing infrared coatings. We only have been doing infrared coatings now for maybe going on 3 years.
Okay.
So we would go to trade shows and we would have people say, "Hey, what's new?" And we'd say, "Oh, we'd tell them what was new," and they're like, "Well, do you do infrared coatings?" And I heard this enough times that over the years I decided, well, I really should be serious about looking into this. We already do thin film coatings. It's a very similar type of process. How hard can it be, right? Well, that's the famous last words. How hard can it be? So it's definitely different. I can't say it's necessarily specifically harder, but it is different. And certainly some things were learned painfully. Some things were learned ahead of time. But some of the differences in working with infrared optics and infrared materials and substrates versus visible substrates are some of the handling concerns. A lot of the optics made out of infrared materials are far more delicate and brittle than some of the glass materials that are out there. We also work a lot on polymers and metals. So, each of those has their own different handling characteristics and nuances that we need to be taken into consideration. Another one that we learned kind of the hard way, unfortunately, was some of the thermal properties of these materials. A lot of these coatings are put on at very specific temperatures, and the temperatures are much more critical in the infrared materials than they are in some of the glass materials. Glass materials, a lot of times you just turn that thing all the way up to high and put the coating on, you get a good result. But a lot of these infrared materials require very, very close control of temperature during the deposition process to put these coatings on. And so what we learned is that some materials actually require specific types of tooling that thermally secure the part without transferring the heat in. We used some stainless steel tooling once for a job, and then the coating, we did the coating, and then the part was perfect in the middle, but around the edges, the coating was failing dramatically. And we realized over time that the heat transfer from the stainless steel into the edges of the part where it was being held during the coating process was enough of a difference to cause that thermal differentiation, a difference of coefficient of thermal expansion to cause the coating to fail at the edges. Okay. So we got into some innovative types of tooling using some heat available polymers that are out there. Aluminum will dissipate heat a lot more quickly. Just really had to learn about how to properly hold parts during the process to be able to modify the process and not cause damage during the coatings. Another thing that was a difficult learn was the cleaning requirements. We use ultrasonic cleaning, hand cleaning, a lot of different cleaning techniques for cleaning visible optics and glass and so forth. But we had to learn some new techniques to get some of the infrared materials properly cleaned. Some of them are very sensitive to certain chemicals, detergents, handling itself, just rubbing the surface can be damaging to certain ones depending on what you're doing and what you're using. So we had to modify and learn some new techniques to clean the optics. And then what was really interesting was some of the packaging and storage of some of these materials. Quickly, when you talk about infrared materials, you're talking about silicon and germanium, you're talking about zinc selenide, zinc sulfide. And then there's a new class of materials called chalcogenide materials out there that are kind of trying to step in and replace some of the germanium specifically because there's a worldwide germanium issue with getting germanium material.
Yeah.
Those infrared materials out of the chalcogenides are very challenging. And some of them, a lot of these infrared materials, but specifically the chalcogenide materials, will oxidize during transportation. So if they're sent from somebody who's polished the part or diamond turned apart, and send it for coating. Just in the process of shipping the part to us for the coating process, they will develop a oxide layer that traditional cleaning methods will not remove. And even, physically abrading the surface with something sometimes still will not remove that. And this was learned the hard way when we did some coatings and we had some either adhesion issues or some staining issues that we just could not figure out. And after doing some research and some development work, we realized that there's this oxidation process that occurs on the surface of these materials. So they really need to be sealed in an airtight container with like desiccant materials, sometimes vacuum sealed when sent for coating. And I think that's an important thing for anybody using infrared materials, that they need to get them coated. Make sure that you properly package these things during transportation if they are going to get coated, because these oxide layers form and they're very challenging to get off and be able to get a pristine surface to put the coatings on.
Right. Okay.
Another kind of variance is that a lot of these materials require a special, what we call an adhesive layer, kind of like a sticky layer to be put on first so that the performing layers will adhere properly to the surface. And over the years, especially working with the polymers, we've learned a variety of proprietary tricks to be able to get things to stick well. So we had to kind of relearn that with what materials can be used as an adhesion layer to promote adhesion and get the best durability and ability to meet the specifications and durability requirements. And then finally kind of is the fact that when you're working in the infrared spectrum, the coatings are much, much thicker than when we're putting on coatings in the visible spectrum, on the order of 10 times to 100 times thicker. And when you're putting on coatings this thick, you've got to take into consideration about, do I have enough material in the chamber to be able to evaporate enough to get these thicknesses, as well as worrying about stress in the coatings. The thicker you put a coating on, inherent stresses start to develop in the thin film coatings that, if they get too thick and they're not stress relieved somehow, will cause to crazing or spalling or problems with the adhesion overall once the parts come out of the chamber. So those are a lot of the kind of the things we've learned as working with infrareds materials. But we've overcome them all, and now we've got good solutions for all of them. So again, some of those were learned easily, some of those were a little more painful, but every time we did have a problem, at least we look at it as an opportunity to learn and get better and make the proper adjustments moving forward.
Yeah. And crystal ball question, I mean, is this going to get easier as new materials get developed, or is there going to be some sort of quick fix or quick, technology fix to some of those issues you're saying? Is your job going to get easier because of where you see things moving, or not, do you think?
Boy, I would like to say yes, but I have a feeling it's quite the opposite. As they develop new materials, every one of them needs to be kind of an R&D effort to try to understand what type of adhesion layer, what type of thermal properties do they have, what type of tooling is going to be required. What might seem like a very similar material from index of refraction and performance as a general bulk material may have a lot of different properties when you're actually putting these thin film coatings on them. So, but I know that there's continued development of new materials, especially, like I said, because some of the standard materials are becoming challenging to get your hands on. So, but we try to get involved as early as possible, and especially when working with customers and special, projects that they have identified a material. And based on the difficulties of some of the materials to process through our different technologies, we really try to get in as early as possible to make suggestions. We've been doing this for a long time. I mean, our company is 51 years old. Again, we've only been doing infrared coatings for about 3 years, but the previous 48 years, we learned a lot. So we can offer things along the way to suggestions of things we've seen, things that will work, things that we know won't work, ways to simplify things, maybe either easier, less expensive, whatever the case may be. We try to pass that along to anybody along the way.
Okay, understood. Thank you. Now, I have had a question come in from about Hyperspectral, which Faisal will answer in a bit. But I just wanted to jump to Philip, if I may. It is interesting, isn't it? Because, as on the one end, Brian is talking about coatings being part of how you need to get the application working properly. Also, adjacent technologies such as AI are a critical component to all imaging now, and probably in some ways as much a universal need, really. So I'm wondering if you could, you're talking about machine vision in oceanic environments. How is AI and thermal imaging with long-wave infrared being brought together? How's that working, and what are you discovering with that process?
Yes. So I think to start with is actually the founder of the company. I think 8 years ago, he did not say, okay, I built something with thermal imaging and AI. He first of all experimented with different types of sensors, starting from LiDAR, from laser, from visual cameras, everything what's on the market. And he figured out, okay, machine vision is actually the way to go to solving the problem. And the problem was he could not see at night, and there was still lots of debris and lots of dangerous objects at sea. Therefore, he were looking for which is the right sensor, and he ended up at the long wave infrared sensors to see at night, and also in let's say fog and dust. That's the sensor to go. However, when you are sailing, or even if in the private sector, but also in, let's say, sailing racing, but also commercial boating, commercial shipping, you do not want to look all the time at the screen. Therefore, by nature, you somehow need, let's say, machine AI to solve this problem, to do the job for you. And actually, our first customers, we originated, our CEI as a company originated from the sailing sector. I mean, I don't know if there are any sailors underneath the participants, but there is the so-called IMOCA class, and those guys are really crazy. They sail alone around the globe. It takes them 3 months, and at some point they need to sleep, and therefore they need to have...
Yeah, Brian's the only one nodding here. I think you're the only person. I think you might be up for something like that.
Yes. So just solving this problem, they need to have a system which protects them, and therefore, obviously, the sensor was picked, the thermal imaging sensor, but then you need the AI to do the job. And so the AI is detecting objects, tells where the object is, also with triangulation and saying the bearing of the object, and gives then an alarm so that the skipper and the boat can still have time to evade. And in other applications like commercial shipping or search and rescue, I already mentioned here, it's a different approach. Here, the AI is helping the operator, the search and rescue guy, to identify a person in the water. I mean, everyone knows that, and it's the same for industrial applications. Brian talked about it. A human can do something very good, but not tired. So at some point, they get tired. And also they need to sleep, as I mentioned before. And their AI is the game changer. And for us as a company, this is our, let's say, this is what we do daily. We select the sensors which make sense, and then we apply AI on it. And then, of course, the whole software on top of it to solve the problem. And that's how we do it. And we figured out over time AI and image sensors is the way to go. And I think we are also pioneers there, because there are not many companies who do long wave infrared cameras and machine vision, and especially in the niche market of let's say, maritime environment. And there we have let's say 7 years of development and a competitive advantage, and we believe we are the, let's say, leaders in this segment.
Okay, so a couple of quick questions, if I may. The AI work that you have been involved with, how many years into it as the organization, been involved? Is it
7 years?
7 years, okay. And then software, AI, comes in lots of shapes and forms.
Yeah.
Have you got your own proprietary software, or do you?
Exactly.
Okay, fair enough.
Everything on our own, even, from starting data collection. We have millions of data collected all around the world. And this is in the end let's call it the main advantage, or the main competitive advantage of our company, because AI is moving so fast. There are coming new models out, and that's also why patents doesn't make sense anymore in this fast moving world. But applying this AI and this to certain application, this is the real challenge. To tailor the products to the needs for the customer. And this can be in the industrial world for processes and so on, but also in our case, our niche market, let's say, maritime world, and detect objects who later increase safety at sea.
Yeah. Okay. So I've got a very specific question has come in from somebody asking, can the human body still be detected from a thermal camera after being in the water for, let's say, 10 to 15 minutes?
Yes. So I always said it in a way that it's obviously thermal cameras can detect heat, let's say, but every surface have a different heat emission, and even you can see waves on the thermal imaging. I mean, therefore you need a very powerful thermal images, which are quite sensitive. but that's possible. I mean, if the difference is it's easier, for example, whales. Whales is a problem with whale strikes. Therefore, also thermal imaging is very powerful because they have a different temperature than the water. But even if it's the same temperature, they emit heat different, and so the image sensor can detect it.
Okay, that's interesting.
And that's always, so last sentence, that's obviously something where AI is a game changer as well, because if it's very little in difference, it's hard to detect it as a human, but the AI, as I said, can do it without getting tired, let's say it like this.
Okay, interesting. Thank you. I'm really sorry, Radoslav. You were asking about hyperspectral, and I was literally about to come to that, and I'm afraid Faisal has dropped out. I guess he may be having some connectivity issues. So what I'm going to suggest is if you can message on this sort of chat function or questioning function any specific questions you have. What we'll do is we'll get those over to Faisal to answer when he is better able to. So huge apologies about the connectivity of him this afternoon. Okay, well, I've still got two terrific speakers, so I'm going to continue as we were. And I want to kind of understand again, and quite a kind of practical end of the process now, which is about how integration personnel, who are responsible obviously for putting together imaging systems, how they should go about finding the right non-visible light source types for their applications and needs. So I guess from a practical, Faisal's actually is still here, just can't connect. But yeah, so how are you finding integration teams are kind of dealing with these sort of different choices? I guess you've already answered the question that they kind of come often with a pretty clear understanding of what they want. So there's a degree to which that's already in place. But what advice can you give for those teams? Philip, I'll stay with you if I may.
Yeah, maybe something different to Brian's business. Let's say is for us, we build more or less off-the-shelf products, and therefore it's part of my role as a head of product management to identify use cases, to identify where there is a need, and then depending on the problem, we select different sensors. So that's why we started to use long wave infrared sensors, but also visual sensors. Visual sensor also to, let's say, identify objects, as I said before, with the higher resolution. But also now when we move more to in the security market and more, let's say, heavy duty cameras, we're now investigating or to use also shortwave infrared and midwave infrared sensors, which have also their advantages. But therefore, also depending on the application, we need to find the right price point, let's say. So as said before, it comes always with the problem, and then we find the best solution. And obviously, that's our strength to apply AI on these different sensors. Something we also do is using radar and sensor fusion. This is then the next part, but the base is obviously always the image with, let's say, visual sensors and thermal images.
Okay. Faisal is back online. So Brian, apologies. I'm just going to pause there and we're going to jump back to him again. Faisal, we want to understand a little bit about hyperspectral. There's a lot of interest out there. We've got a specific question about what do we gain with hyperspectral for computer vision over color or multispectral? And then more generally, I just wanted to ask a little bit about the market gaps that you can see for hyperspectral imaging. So over to you.
Okay, can you hear me?
Yes, we can.
Okay. I might actually lose the signal at the same time, but maybe just quickly then I'll cover these 3 points that I see as a gap which hyperspectral imaging is covering in the R&D side. One of the key elements that traditionally people have been bothered with is the choice between high resolution, get either the detailed images or the detailed spectra, but not both at the same time. So now in Sony, we have been working on a really kind of a combined solution in which it would provide high spectral resolution, but at the same time, the location of that spectra as well. For example, a biomedical researcher to detect a particular protein or a disease marker in it. We enable an electronics manufacturer, for example, to find. So that's one gap. Efficient experimentation enabling hyperspectral systems generally, like Sony's, they can shift between spectral ranges easily. That addresses the gap about
we've lost you again, Faisal. I'm sorry. I tell you, Faisal, if you can just perhaps answer in the chat the specific question about the hyperspectral for computer vision, I will read that out for you if that's okay. I think that might be easier because we're just not getting enough of your feed, I'm afraid. Brian, let's come back to you if we may. So I just wanted to ask about the integration process from your perspective. Obviously, you're dealing with a specific element of the vision system, but how do you see that working in real life?
I mean, from a very kind of global look, like the 50,000-foot view, I mean, very simply, kind of more like Philip said earlier, is first you have to define the imaging objective. What are you trying to image? Are you trying to do a surface penetration, surface analysis, temperature mapping? What is the goal of what your overall application that you're trying to do is? And then based on that, you have to understand your target material interactions, right? So what is it going to be, something that you need near infrared for, or long wave infrared? Is it a thermal thing? Is it a moisture or a skin kind of thing? Is it a medical type issue? In some cases, actually, we haven't talked about it, but ultraviolet is also an area that can be used for some of these as well, but that's a separate discussion. So, and then based on those two things, you have to match your source type to your application, right? So you have to choose both your materials, your lasers, your detectors, your sensors, all those things, depending on what those application things were. But I think a really critical one that often gets overlooked until late sometimes in the game, and this is where we fit into it, are where coatings may help. And that's where sometimes we, unfortunately, because we are typically one of the last things produced in an imaging system, coatings are oftentimes rushed because people are late on their jobs. So the job gets to us and then the pressure's on. Hey, my job's already 2 months late. You got to get this coating done in 5 minutes. That's always a lot of fun. But then sometimes they're just overlooked altogether. It's like, hey, we put the system together and we're not getting enough transmission based on the models we thought we would. So then it's, rapid, fire. What can we do to increase the transmission? Should we put an anti-reflective coating on it? Should we try to filter out some of the other wavelengths of light using a bandpass filter? So those things are something that, really, that's why we try to get involved as early as possible with the engineers trying to design a system if possible, because we can help them avoid some pitfalls of forgetting about coatings or little nuances that may be overlooked in the overall design process.
Yeah. And those teams, I mean, how close to the technology do you find those integration teams? I mean, presumably they all come to every opportunity with a bit of bias, right? They might not know much about coatings, or they might hate AI. I mean, can't quite imagine that being the case, but it's possible, right? I mean, are you able to neutralize some of these biases that you see in teams, or are they generally fairly neutral about everything, and therefore, it's just perhaps timing, as you were saying, Brian, about when they're thinking about some of this stuff?
It's all over the place because, we get inquiries directly from engineers. We get them from purchasing departments. We get them from people with various levels of understanding of what the actual optical system is.
Yeah.
We prefer to work with the engineering teams, but engineers have a tendency to over-spec things. I will say, being an engineer myself, I'm not afraid to call myself out. And sometimes we get people that just put specifications out there that simply don't make sense. I mean, I've had requests for something. They wanted to transmit 60% of the light and reflect 60% of the light. And I'm like, well, I don't have 120% of light to do something with. So that's why we really try to get in as much as possible. And then, a lot of times there's a specification that'll be provided that they want 99.999% transmission. And in many cases, that may be able to be done. But then when you find out what's involved with doing that and the cost associated with it, well, all of a sudden now 99.9 is going to be just fine. So, trying to keep in mind what you really need versus what your wish is, right? Sometimes perfect is the enemy of good enough. And sometimes we have a tendency to try to go for perfect when this thing has to be manufacturable, it has to be cost effective, it has to be, really, something that can actually be done in a reasonable fashion. So we try to step in with that mindset because we have seen so many applications. I mean, every day is a new application for us. We, unlike Philip, who makes a standard off-the-shelf product, we do nothing off the shelf. Everything is custom. So every day we're having conversations with engineers about new challenges, new opportunities, new struggles that they're facing. And so we've learned a lot over the years, and we try to get involved with that.
Okay. And Philip, I mean, what about your experience of these integration teams? You know, is it a fairly smooth, obvious process, or are there lots of road bumps along the way?
Well, you know, for us, it's a product development. It's not like that there is a project with a customer and there's certain requirements. I mean, we do certain customization, yes, but if it comes to a new product development, then it's like a normal process with first of all a concept, then a feasibility studies of the engineering team, and then it starts the development with testing, quality testing, and then with customers a beta phase. So this is a process where we started as a startup 7 years ago, and when I joined the company 5 years ago, I think we were 10 people where there were no processes and nothing were in place. And now we are more than 70 people growing, and I mean, the process as established, we gained a lot of knowledge to develop new products. I think this is part of our daily business. So
And product development is a good way of capturing this. What does a time frame look like? I mean, discussion one, January this year, say, when do you typically see a conclusion in terms of delivery and then application in place? Is there a common sort of time frame?
No, not at all. I mean, first, we need to deal with our resources, and we have lots of different products, versions, product families in the field. This is something where also, new products in terms of hardware, but also in software. So let's say new software features, that's something improved AI, improved machine vision. This is daily business, and we deliver software updates. So it depends. I mean, sometimes we have bigger projects with new cameras. I managed before mid-wave infrared cameras. So this has obviously a longer time. But in principle, we are quite good to, let's say, put different components, different cameras, apply our AI. That's something we can do quite quick as well.
Okay, Faisal, I can see you're with us, but I'm wondering whether you've got a connection to answer the question about hyperspectral with computer vision over color or multispectral. What's the big gain? Are you able to answer that one?
Yeah, okay. I think I've got a few seconds of the time that I can utilize for that. You got to understand, first of all, what's the benefit of hyperspectral imaging? The hyperspectral imaging, the more number of wavelengths that you add to a solution, it costs. And Mark actually, Brian earlier talked about the cost element of solutions as well. There's one thing to just want something which is great. Another thing is how manufacturable, deployable, and cost efficient it is. Generally, the purpose of the hyperspectral imaging is that you can discover something which has not been seen before. Whereas generally you deploy computer vision applications where you have a very defined environment. You want to sort of measure or see something very particular. Then what you want to do is research what the bandwidth, or the bands are, which might be essential to either identify chemical constitutions, physical compositions, whatever that you are trying to measure. So the benefit of hyperspectral imaging is generally in the discovery part, not necessarily in deployment, because at the end, generally the deployment for mass use cases is very cost efficient, trigger-based solution. So as long as you are in the discovery mode, you want to differentiate things, and also if you want to have not just the spectral resolution, but maybe identify the spatial position as well, that's where hyperspectral combined solutions would come really handy. And Sony actually has been working on spectral cameras which provide really high-end spectral resolution, but at the same time spatial resolution as well. So this way, for example, a biologist not only could identify a certain gene, but also location within the cellular distribution. An electronic engineer could not only identify a defect, but the position on the wafer as well. In a similar case, if you're applying a vision where you need this kind of an information which needs to be enriched on each pixel level, you want to go for more number of wavelengths. Otherwise, the ideal use case is that you stick with small number of band gaps, the small number of bands, and minimize the cost for a solution.
Okay, Thank you. That's good. I mean, it's always good when we do these sessions when there's a kind of neat little takeaway there, and there you had one. Hyperspectral discovery, not deployment. That would be my headline from that. Thank you, Faisal. That was helpful. Right, crystal ball time. I always like to kind of ask the obvious question about the future. You know, what trends do you see emerging in the next few years? And I guess this is nobody will necessarily hold you to account, so you can be as ambitious or as forward thinking as you like. But I'm wondering, anybody want to start? What trends do you see emerging in the next few years? Faisal, do you want to have a go if the connection's still there?
Yeah, just to take the advantage of the go that I have with the internet, maybe I will pick with, I think, which Philip was mentioning. I think the AI introduction and the getting the assistance for the solution is probably a really good, strong trend, which is going forward. And it's both in the multispectral, hyperspectral solutions, or otherwise generally non-visible regimes, then you would be looking at the advanced illumination technologies, likely also coupled with the growth of multispectral, hyperspectral solutions. At the same time, with the high performance and affordable SWIR imaging, I think would be a really strong market pull from this direction. And this is why Sony is also generating these second generation in-gas SWIR sensors, because of the well-integrated solutions or the market space within Europe as well as outside that. So I think these 3 or 4 trends I see as sort of a major development in the future, but also future of these different sensors together would actually form new applications and really useful use cases, which currently are separately addressed by individuals.
Okay, thank you. That's good. I mean, AI is you know, kind of in every discussion I ever have on any topic in this whole kind of broad photonics imaging world. Philip, that seems like a nice segue into you, because obviously it's a big driver for you at the moment. Any other trends, or do you just see AI being the dominant one?
Well, I mean, in our domain is the same as in the automotive industry. It's, you know, autonomous driving, and therefore machine vision is, let's say, a key element to it. This is something where also in shipping, in boating, this is also a trend, obviously, and therefore, but there is no way around machine vision. Here I see obviously lots of trends to also control boats, which is more or less the machine vision is the sensor. But I mentioned before sensor fusion. So machine vision is only one sensor. There is also radar, LiDAR, and this is a trend I see in our domain. And in specific, when it comes to thermal imaging, a trend where at least we are hoping to, and our customers are hoping to, is that the sensors have a high resolution, because that means with higher resolution you have more pixels per object. You can either detect further or objects further away, or you can have a wider angle, which is obviously for situation awareness also very important. So I hope personally that also with thermal imaging gets more and more used in different applications, because and more volume, that there is lots of development there, and also the prices will drop in the future, or at least the quality gets higher and higher.
Interesting. Okay. Are there any boats being kind of routinely piloted without human intervention? You know, you talked about driverless cars. Do we have
USVs? Yes. So I mean, autonomous boats, USV. This is a market trend which everywhere. Imagine just, you know, for let's say security application monitoring. Imagine wind farms or this internet cables laid under the oceans. They need to be surveyed, and obviously also in military defense applications, you do not want to send people. There definitely machine vision based on cameras makes a huge difference.
Okay, makes sense. So no chance of the cruise we all might be going on over the summer being piloted without that, but certainly on some of the smaller, more you know, kind of extreme condition kind of vehicles, I can see that. Having been in a driverless car in San Francisco earlier this year, I can say that I felt very safe, so nobody should be worried. Brian, over to you then. What's the order book looking like, and what do you think it will look like in the coming years?
So I'm going to kind of echo what the other gentleman already said. I think that as we're starting to see thermal sensors and imaging cameras become a little bit less expensive, you're going to start to see them pop up in a lot more places. A lot of the smart home automation type stuff, Probably even in some starting to see more thermal imaging in your phones, the cameras in your phones. We'll start to see them pop up in just a variety of different places for security and things like that, preventive maintenance, where you can start watching for, equipment starting to overheat early on and be able to detect it and catch that well before a piece of equipment goes down. One of the biggest ones that both guys touched on, and this is really Philip's bandwagon here, is the integration of AI with thermal imaging. I mean, it just makes total sense. AI as a whole, as Philip mentioned earlier, is just, people that are not really familiar with AI need to become familiar with it, because it's not going away. It's only getting stronger. It's getting better. It's not just ChatGPT. There's all kinds of things out there. I know a lot of people are scared of it. A lot of people are fearful of it. Bottom line is learn it, understand it, become comfortable with it, use it to your advantage, and you'll be ahead of many people if you do that. Because a lot of people just want to look the other way and not learn about it, be scared of it. And it's coming, it's here, and it's getting better. And so let's try to make it a positive experience rather than a negative one. And then I think the other one that Philip as well touched on was the multimodal system, right? Where you're having both a combination of LiDAR and radar and thermal imaging and visible imaging all in a single system to give you the best possible imaging situation for whatever the case it may be, most often in terms of like a security or a safety issues. I saw a recent video on the internet where a Tesla was driving down a road in the desert, and they had painted, it was just a simple lane in the middle of the desert, and they had painted a curtain in front of it that looked exactly like the road continued. And without the thermal imaging, that Tesla went right through the curtain, because the visible stuff thought, hey, I'm still seeing the road, I'm still seeing the lines, I'm still seeing everything I should see. There's a perfect example where the thermal imaging or other types of infrared imaging would be able to detect that there's actually an obstruction in the road and we better not go through this thing.
Yeah.
So you're going to find these things. Again, I mentioned the opportunity for, the night vision for cars and things like that. It's going to continue to pop up in more and more places. Probably plenty that we haven't even thought about yet. And that's what's kind of exciting and interesting, and what makes these types of environments really fun to work in.
Yeah, fabulous. No, well, there's another very clear takeaway there. Embrace AI. I'm sure that's something all of our panel will echo.
I just want to say, echo what Brian said in terms of the warning as well, because just earlier today I was having this internal meeting and we talked about AI, and one of the things that I was just saying there as well, that people have this fear that somehow AI is going to replace them. I don't think AI is going to replace people. It's going to be the people who are using AI is going to replace them. If you are not equipped with this, with the knowledge of how to use that, there will be somebody else who will be doing your job better than you. And the integration of AI is actually taking out the laborious job and letting you do really smart things much faster. That's the entire purpose of it. And if you're getting scared of it, somebody else is going to take the advantage of it. Of somebody who might be less even smarter than you, but he can do the job much efficiently because AI can assist that person more effectively. And the second point is, again, I think Brian also touched, and Philip earlier said too about this, and I said it is fusion, and I would also call it more like a democratization of these components and the technologies which actually can go towards the consumer and consumer use cases in a much more cost-efficient manner, in a much more smaller footprint, and integrated with the sensors, which we have not seen integrated before, because we did not have the packaging technology or miniaturization capabilities, or simply the ways to sync those sensors together to get a meaningful data out of that. And AI will allow you to actually make sense of the data which couldn't be made sense of before. I think this is where a lot of innovation ground is still open for most of the companies to work at.
Yeah, no, absolutely. I mean, it's certainly a topic we will be coming back to, because I think it's fast moving, very dynamic, and very exciting, because there's an awful lot that I can see, just in the last 18 months, 2 years, that felt a little bit beyond our reach then, and now is becoming more and more routine, AI being a very obvious example of that. Okay, well, look, unfortunately, we have run out of time today, so that brings us to the end of today's session. This online panel discussion will remain accessible on the Imaging and Machine Vision Europe website, and that is imveurope.com, and then it will eventually turn up on our YouTube channel. We'll also be creating an online article from this, so please spread the word among your colleagues if you've enjoyed the presentation. It's been great to have them, particularly having Faisal and Brian, who are part of our Photonics 100. We have just closed the list closed the nominations window, I should say, for the 2026 list, and we will be announcing that that later on in the fall or the autumn, depending on which language you speak, and more on that in due course. Philip, you've been brilliant as well. Thank you ever so much for joining us. It's been really interesting to hear what CAI are doing. And I'd just like to thank, obviously, the Europa Science production team working hard in the background, and of course our partners Navatar, who make events like this possible. Thank you to everyone who's taken the time to watch the online panel discussion and to send in your questions. There will be more future sessions. We're taking a short break across the summer, but we're working on the programme for September onwards, so watch this space, and hopefully we will see you at one of those in the near future. Thank you again. Thank you, everybody. Apologies about some of the connectivity issues there. We will speak to Faisal about getting some of his quotes sharper so that we can use them in the article, so that will be good. But thanks again to everybody, and have a great rest of the day wherever you are. Take care.
Thank you.
Thank you.
Bye.